Hello. In the last class, we have studied in detail regarding the salient features of modern periodic table constructed by Moseley. The elements in the periodic table are arranged according to the modern periodic law, and they have divided them in the form of a vertical columns called groups and horizontal rows called periods. And also we have studied that the elements are divided into four blocks. Whatever the elements are available now, they are all divided only in the form of four blocks, depending on the valency electron enters into the subcells. So today I am going to deal with the classification of elements into S, P, D and F block elements. So coming to the classification of elements into S, P, D and F blocks. Whatever the elements existing in the periodic table, divided them into only four blocks or only four categories, that is S, P, D and F blocks. The classification of elements on the basis of electronic configuration divides them into four blocks, that is S block elements, P block elements, D block elements and F block elements. Depending upon the nature of atomic orbitals into which the last electron enters. So coming to the periodic table, here in the periodic table, totally we are going to observe 118 elements. In the periodic table, we are going to observe totally 118 elements till date. All the 118 elements are divided into only four categories or only four blocks, namely S block, P block, D block and F block. The elements belonging to the left side of the periodic table, particularly first A group elements and second A group elements, which are so called as alkali metals, that is first A group elements, and alkaline earth metals are going to be referred as a S block elements. Elements placed at the right side of the periodic table, starting from boron family to noble gases, except helium, these are going to be called as P block elements. And also we know that in between S and P block elements, there is a place for D block elements. In between S block and P block elements, there is a place for D block elements, and at the bottom of the periodic table the F block elements are arranged. So totally the modern periodic table has been divided into only 4 blocks, namely S block, P block, D block and F block. Then when we see the classification of elements into S, P, D and F blocks, then what are S block elements, what are P block elements, D block elements and what are F block elements? Elements in which the valency electrons enter into ns orbital are called S block elements. The elements in which the valency electron enter into ns orbital are called as S block elements. Particularly in S block, there are two groups, namely first A group and second A group. First A group elements and second A group elements were belonging to S block. That is, the elements of the first A group, that is alkali metals like lithium, sodium, potassium, rubidium, cesium and francium were belonging to alkali metals, and the elements of the group second A, which are so called as alkaline earth metals like beryllium, magnesium, calcium, strontium into S block. The valence cell electronic configuration of these elements varies from ns1 to ns2. That is, the valence cell electronic configuration of S block elements varies from ns1 to ns2, and the general electronic configuration of S block elements can be represented as ns1 to 2. That is, if it is in the form of ns1, it corresponds to configuration of alkali metals, and if it is ns2, it corresponds to the configuration of alkaline earth metals. For example, as I have shown in the example number 1, that is, in alkali metals, the valency electron enters into ns1, that is ns subshell as ns1. Let us see some of the examples. For example, lithium having atomic number 3, its configuration can be written as 1s2, 2s1. In lithium, as its atomic number is 3, 2 electrons are entering in the form of a 1s subshell as 1s2 and remaining 1 electron, that is the valency electron, that is the third electron in lithium, is entering into the second S subshell as 2s1. Coming to the second example, that is sodium. As the atomic number of sodium is 11, its configuration can be written as 1s2, 2s2, 2p6, 3s1. The last electron, that is 11th electron in sodium, is entering into 3s subshell as 3s1. The remaining 10 electrons, that is the first 10 electrons are entering into the previous orbitals, that is in the form of 1s2 and 2s2 2p6. In 1s2 and 2s2 2p6, 10 electrons are entered, and the last electron, the 11th electron, which is called as a valence electron, is entering into the third subshell in the form of 3s as 3s1. Hence, sodium is also a alkali metal. Likewise, potassium, the configuration 4s1, rubidium, its configuration, that is valence shell configuration 5s1, cesium, its valence shell configuration is 6s1, and whereas that of francium valence shell configuration is 7s1. In all the alkali metals, starting from lithium to francium, the valency electron is entering in the form of 2s1, 3s1, 4s1, 5s1, 6s1 and 7s1, where n equal to 2, 3, 4, 5, 6 and 7. Hence, the general electronic configuration of alkali metal can be represented as Ns1. In all these elements, the valence electron is entering into the Ns subshell in the form of a Ns1. Hence, alkali metals are belonging to S block. Coming to the second example, that is alkaline earth metals. In alkaline earth metals, that is second A group elements, the valency electron enter into Ns subshell as Ns2. That is, when we come to the example of beryllium having atomic number 4, its configuration can be written as 1s2, 2s2. As the atomic number of beryllium is 4, configuration is 1s2, 2s2. Here the valency electron. In this example, there are 2 electrons left to enter into 2s subshell, and these 2 electrons are called as valence electrons, and these enters into the s subshell in the form of a 2s2. Hence, beryllium is a s block element. Likewise, magnesium having atomic number 12, magnesium having atomic number 12, its configuration is 1s2, 2s2, 2p6 and it is 3s2. In the valence shell, the remaining 2 electrons are entering in the form of a 3s subshell as 3s2. Hence, magnesium is again a s block element. Likewise, calcium configuration, particularly a valence shell configuration of calcium is 4s2, that of strontium is 5s2, barium is 6s2 and radium is 7s2. The general electronic configuration of alkaline earth metal is represented as Ns2, where N equal to 2 for beryllium, 3 for magnesium, 4 for calcium, likewise 7 for radium. Hence, the general electronic configuration of alkaline earth metals can be represented as Ns2. So here in the first A group, that is alkali metals, and in the second A group, that is alkaline earth metals. Both the group elements are receiving their valency electron in the form of a NS1 or NS2. That is for alkali metal NS1 and alkaline earth metal it is NS2. Hence the elements belonging to first A group and second A group are going to be called as S block elements depending upon the valency electron into which it enters. Coming to the P block elements, as we know, the classification of elements is divided them into 4 blocks, namely S block, P block, D block and F block. When we come to the P block elements, the elements in which the valency electron enters into N-p orbitals are called P block elements. That is, the electronic configuration, especially the valency electron which it enters into a particular subcell are going to be called as a particular block elements. So as we know, in S block elements, the valency electrons are entering into N-p orbitals. The elements belonging to third A group, that is boron family. The elements belonging to fourth A group, that is carbon family. Elements belonging to fifth A group, that is nitrogen family. That is, the elements belonging to third A group, that is boron family. Elements belonging to fourth A group, that is carbon family. Elements belonging to fifth A group, that is nitrogen family. Elements belonging to sixth A group, that is oxygen family. Elements belonging to seventh A group, that is halogens. And the elements belonging to zero group, that is noble gases, except helium were belonging to P block. What are P block elements means? The elements in which the valency electrons enter into N-p subcell are going to be called as P block elements. Particularly, the elements belonging to boron family, carbon family, halogens and noble gases. When we come across with the noble gases, except helium, the remaining elements like neon, argon, krypton, xenon and radon were belonging to P block. Here I am going to say that there is an exception for helium, because when we write the electronic configuration of helium having atomic number 2, the configuration indicates that its configuration is only 1s2. No one electron is left in helium to enter into P subcell. Hence, helium is not a P block element. Once again, elements belonging to boron family, carbon family, nitrogen family, oxygen family, halogens and noble gases except helium were belonging to the P block. Coming to the examples of P block elements. When we see the electronic configuration of P block elements, especially a third A group, that is boron family element, as the atomic number of boron is 5, as the atomic number of boron is 5, its configuration is 1s2, 2s2, 2p1. In boron, 3 electrons are entering into the valence shell, particularly 2 in the form of a 2s subshell as 2s2 and 1 electron in the form of a p subshell as 2p1. Here in boron, the valence electron is entering into the p subshell as p1, hence boron is a p block element. Likewise, when we come across with the element aluminium having atomic number 13, its configuration can be represented as 1s2, 2s2, 2p6, 3s2, 3p1. Again, in aluminium, the last electron is entering into 3p subshell as 3p1. Hence, aluminium is also a p block element. Likewise, in third A group, boron, aluminium, gallium, indium and thallium receives their valency electron in the form of a p1. Hence, the general electronic configuration of boron family is represented as Ns2 Np1, where N equal to 2 to 6. So this is the general electronic configuration of boron family, that is Ns2 Np1 is the general electronic configuration of boron family. Coming to the next example, that is carbon family. As the atomic number of carbon is 6, its configuration can be written as 1s2, 2s2, 2p2. Here in the p subshell, the 2 electrons of carbon are entering into 2p subshell as 2p2. Hence, carbon is a p block element. Like carbon, the silicon having atomic number 14, its configuration can be written as 3s2, 3p2, whereas that of germanium and remaining elements of the fourth A group is represented as P2. That is, in all these elements, 2 electrons are entering into 2p subshell, or in 3p, or in 4p, or in 5p, or in 6p subshell as P2. So hence the general electronic configuration of carbon family can be represented as Ns2 Np2, where N equal to 2 to 6. Coming to nitrogen family, as the atomic number of nitrogen is 7, its configuration can be represented as Ns2, comma, sorry, 1s2, comma 2s2, 2p3. In nitrogen, as its atomic number is found to be 7, 2 electrons are entering in the form of a 1s2, 1s subshell in the form of 1s2, 2 electrons are entering into the 2s subshell as 2s2, and remaining 3 electrons are entering into 2p subshell as 2p3. Hence, the element nitrogen is belonging to a p block. Not only a nitrogen, all the members of the nitrogen family were belonging to p block, and their general electronic configuration can be represented as ns2 np3. ns2 np3 is the general electronic configuration of nitrogen family. Coming to the next example, oxygen family. As the atomic number of oxygen is found to be 8, its configuration can be written as 1s2, 2s2, 2p4, 1s2, 2s2, 2p4. In this element, the 4 electrons are entering in the form of a p subshell, that is in the form of a 2p as 2p4. Hence, oxygen is a p block element. Likewise, sulfur, selenium, tellurium and polonium were receiving 4 electrons in the form of a p subshell. Hence, oxygen family is also belonging to a p block, and its valence shell configuration, that is the valence shell configuration of oxygen family, is represented as ns2 np4. Coming to the next example, halogens. As the first member of the halogen fluorine is having atomic number 9, its configuration is 1s2, 2s2 and 2p5. In fluorine, totally 5 electrons are entering into p subshell as 2p5. Hence, the element fluorine is a p block element, as it is receiving 5 electrons in the np subshell. Especially in fluorine, it is 2p as 2p5. Coming to the another example of halogen, that is chlorine, having atomic number 17. That is, chlorine is 17. Configuration can be written as 1s2, 2s2, 2p6, and it is 3s2, 3p5. 5 electrons of chlorine are entering into the 3p subshell as 3p5. Hence, chlorine is a p block element. Likewise, the elements of the halogen family, fluorine, chlorine, bromine, iodine and astatine, are receiving 5 electrons in the outermost p subshell. Hence, halogens belonging to a p block elements. The valence shell configuration of p block elements can be represented as ns2 np5, where n equal to 2 to 6. Coming to the last group, that is zero group of the p block elements. As we know, the elements are arranged in the modern periodic table on the basis of electronic configuration, and elements are also divided into particularly S block, P block, D block and F block, depending upon the nature of the valency electron which it enters. So coming to the noble gases, that is the zero group of the periodic table. Coming to the first member, helium, as its atomic number is found to be 2, configuration is written as only 1s2. In helium, no electrons were left into enter into the p subcell, as the atomic number of helium is only 2, configuration is 1s2, no electron is left to enter into the p subcell. Hence, helium is not a p block element. Helium is not a p block element, even though for the rational classification of the elements and the construction of the periodic table and to see the symmetry of the periodic table, the element helium is placed along with the p block element, but actually helium is not a p block element. Coming to the rest of the family members like neon, argon, krypton, xenon and radon, all the elements except helium were receiving 6 electrons in the p subcell as 2p6, 3p6, 4p6, 5p6 and 6p6. Hence, the elements belonging to noble gases except helium were belonging to p block. Hence, the general electronic configuration of the noble gases can be represented as Ns2 Np6, where N equal to 2 to 6. So this is all about the classification of elements into S as well as p blocks with an example. Coming to the d block elements, the elements in which the differentiating electron means the valency electron which enters into n-1 d orbital of n-1th main cell are called d block elements. Coming to what are d block elements? The d block elements are those elements in which the valency electron, that is differentiating electron, enter into n-1 d orbital of n-1th main cell are called d block elements. D block elements are also referred as transitional elements, as these elements receive the valency electron into the penultimate orbital, that is one orbital before the nth orbital. Hence, D block elements are also called as transitional elements and are classified into 4 series. D block elements are classified into 4 series. As I am telling you, the D block elements are further divided into 4 series called as 3D series, starting from atomic number 21 to atomic number 30, that is scandium to zinc, is regarded as a 3D series elements. Element having atomic number 39, that is yttrium to cadmium, atomic number 48, is called as 4D series elements. As you know, the D block elements are again divided into 4 series called as 3D series, starting from atomic number 21 to 30. 4D series starting from atomic number 39 to 48. 5D series starting from atomic number 57 to 80. And 6D series starting from atomic number 89 to atomic number 112. These are the 4 series, that is D block elements are further divided into 4 series called as 3D series, 4D series, 5D series and 6D series, depending upon which the valency electron enters into 3D subcell, 4D subcell, 5D subcell and 6D subcells respectively. As coming to the D block elements, according to the definition, the elements in which the valence electron enters into n-1 d orbital of n-1th main cell are called as D block elements. D block elements are also called as transitional elements and are classified into 4 series corresponding to the filling up of 3D subcell, 4D subcell, 5D subcell and 6D subcell respectively. The valence cell or the general electronic configuration of D block elements can be represented as n-1, D1 to 10, ns 1 to 2 is the general electronic configuration of the D block element. The elements in which the valency electron entering into 3D subcell are called 3D series elements, or it is also called as first transitional series. Similarly, the elements in which the valency electron enter into 4D subcell are called 4D series elements, or it is also referred as a second transitional series. The elements in which the valency electron enters into 5D subcell are called as 5D series elements, or simply a third transitional series elements. And the elements in which the valency electrons enter into 6D subcell are called as 6D series elements, or simply fourth transitional series. Coming to the last type of classification of elements, that is F block. The elements in which the valency electron enters into n-2f orbital of n-2th main cell are called as F block elements. According to the definition, the elements in which the valency electron enters into n-2f orbital of n-2th main shell are called as F block elements. F block elements are also called as inner transitional elements. F block elements are also called as inner transitional elements because in these elements the valency electron is entering into the anti-penultimate orbital, that is into the n-2th main shell. The electron which enters into the anti-penultimate orbital are going to be called as inner transitional elements, and there are two series, that is 4F series and 5F series. 4F series elements are called lanthanides or lanthanons or lanthanidos. According to the various languages of the world, 4F block elements are referred as lanthanides, lanthanons or lanthanidos. Likewise, the 5F series elements, the elements belonging to 5F series are called as actinides or actinons or actinidos. The valence shell electronic configuration of the F block elements can be represented as n-2 F0 to 14, n-2 F0 to 14, n-1 D0 to 1 and ns2. n-2 F0 to 14, n-1 D0 to 1, ns2 is the general electronic configuration of F block elements. Both the series consist of 14 elements. The elements placed at the bottom of the periodic table. As you know already, the elements placed at the bottom of the periodic table are referred as F block elements. In F block elements, there are two series, namely 4F series called as lanthanides and 5F series called as actinides. Both the lanthanides and actinides consisting of 14 elements each. So this is regarding the classification of elements into S, P, D and F blocks. Again, in my next class, I am going to deal with the atomic radius and ionic radius and their variation along the group and a period. Thank you.